Let's analyze these functions by combining everything we've talked about so far, including the amplitude, the period, the phase shift, which is new, and we talked about recently, and then the vertical shift. And then we'll also note if these graphs have been reflected or not. So let's take a look at these functions down here. Amplitude is the easy part. Amplitude is the a value, the number in front of sine or cosine. So in this case, my amplitude 7. It's always positive. A negative value just tells you you've reflected the graph or not. To find the period of a sine or cosine function, same as we've always done, it's 2 pi divided by the b value. The b value is the coefficient of x, so in this case it's 2 pi divided by 1/4. Simplifying that, I get a period of 8 pi, just like we've always done. I'm going to skip phase shift. Let me do vertical shift. Vertical shift is your k value, your number being added or subtracted to or from the function. In this case, there isn't anything being added or subtracted at the end, so my vertical shift is 0. The midline's not been moved. And then finally, my phase shift is going to depend on what the h value is. Well, a couple things about that. First of all, as the h value has always done, it's going to move the graph in the opposite direction of what it says. And then with sine and cosine graphs, with any trigonometric graphs, the h value itself is not the phase shift, but rather h divided by b. Just like the period's not the b value itself, the phase shift is not the h value itself, it's h divided by the b value. So in this case, my phase shift is going to be positive pi over 2 divided by 1/4. So I can either multiply by the reciprocal or use a calculator if I need to, but basically I need to do 1/2 divided by 1/4, and the pi's not canceling out. 1/2 divided by 1/4 gets me 2, and that pi stays there. So I'm going to make a note too that since it's positive, since my original h value was negative, my phase shift is positive. That's going to be moving my graph 2 pi to the right. The opposite direction of what that said. So that's kind of how this analysis works. Oh, one other thing, the reflection. Since the amplitude was a positive value, this graph has not been reflected. It's going to be your normal sine or cosine wave. Okay, so I'll do one more example and have you guys try the bottom two on your own. So, alright, so just like we talked about, I'm again dealing with a sine or cosine graph. It doesn't matter, they're all going to behave and be analyzed the same way. My amplitude is the number in front of the sine or cosine. So in this case, my amplitude is pi over 5. Not negative pi over 5. Amplitude's always positive. What that negative indicates, I might as well note it now, that negative indicates that this graph has been reflected. It'll be flipped over the x-axis when I graph it, from what I'm used to seeing. Period is still 2 pi divided by the b value, right there. So 2 pi divided by pi gets me a period of 2. In this case, the vertical shift is the number being added or subtracted. So in this case, my phase shift is -1, which I can note if I want to. That'll move the graph down 1. And then finally, the phase shift will depend on what the h value is. It's not that value itself, it's the opposite of that, divided by, again, the b value. So -2 divided by pi, which is kind of a weird one. Normally we won't see phase shifts that look like that, but in this case I just wanted to give you a weird one. So there is my analysis of that graph. So at this point I want you to pause the video and try these bottom two on your own, or you can let the video play through and my work will pop up. So there's the answers I came up with. Hopefully you guys came up with the same things out there. If not, you can ask me in class. And then again, just notice that that phase shift is the opposite sign of what you see in the parentheses. So if I have a positive sign up there, my phase shift will be negative.